Hi guys, today we are going to see about symmetric of matrix. Okay, hope you remember the transpose of matrix, right? So that is, I already told about transpose of matrix. Once again I will say, if I am having a matrix, A, and if I am changing all the rows to column, then it means that I have taken the transpose of that matrix. If I change this kind, then I will say it as transpose. That is, all the rows I changed here as column, or vice versa. Everything will give the same answer. So from this only I am going to see some provings and some properties. That is, first thing is symmetric matrix. That is, if A matrix is equal to A transpose, then we will say it as an symmetric matrix. Consider this matrix A is equal to AB and BD. And if I take the transpose of this matrix, that is, I am changing my rows into column in A transpose matrix, which will be A, B, and I am changing this, so B, D, which is equal to A. So then we will say it as an symmetric matrix. So when we will say matrix is a symmetric matrix, when A is equal to A transpose. Okay. Then we will say skew symmetric is if A transpose is equal to negation of A. That is, if I am having this matrix Q, take it as an example. If I take a Q transpose, how it is going to be? 0, minus 2, 7, 2, 0, minus 3. That is, I am making all the rows to columns or column into rows. Both are possible, so I am making like this. So next is minus 7, 3, 0. If you compare these two matrices, you can able to see that Q and Q transpose only has the difference of the negatives, right? Here if it is positive 2, here it will be negative. Negative 7 is there, so positive 7 is there. Negative 2 is there, here positive 2 is there. So this kind of matrix we will say it as an skew symmetric. So what previously we saw is symmetric matrix. Symmetric matrix means the transpose of the matrix will be equal to the matrix, and here transpose of the matrix will be equal to negation of the matrix. Okay, so this is known as skew symmetric. Okay, so from this, what first thing is how to form a skew matrix and how to form a symmetric matrix. If I want to form a symmetric matrix, if whatever matrix I can take any matrix, A is equal to 1, 1, 3, 5. If I want to make this as a symmetric matrix, what I can do is, if I take a transpose of this matrix, that is A transpose. If I take transpose of this matrix, what I will get? 1, 3 and 1, 5, right? If I add these two matrices, that is A plus A transpose, I will get 2, 4, 4, 10. Now this matrix will prove the symmetric matrix. If I take transpose of this matrix, what will be my answer? 2, 4, 4, 10. Okay. So to make a symmetric matrix, what he has to do is, you can take any matrix and take the transpose of it and add these two matrices to form the symmetric matrix. So this will give the symmetric matrix. Similarly, the same operation, if I do minus instead of A plus and A transpose, if I do my subtraction, I will get my skew symmetric. That is 0, minus 2, 2, 0. If I take transpose of this matrix, what I will get? 0, 2, minus 2, 0, right? So this is having only the numbers is changed by their sign, correct? So I can say it as a skew symmetry. So this is important property that okay. So next, how to express the matrix in the form of sum of symmetric and sum of skew symmetric. That is, this is sum of. So we already know that if I take a matrix and if I take transpose of it and add, what I will get? I will get symmetric, right? Similarly, if I take a matrix and take transpose and if I subtract it, I will get skew symmetry. And by dividing by multiplying into 1 by 2, if I add these both, I will get the original matrix what I have taken. So now we can see one example on that. I am taking a matrix. Let it be 1, 3, 5, 2. Okay. So let it be it as A. So what will be my A dash? A dash is equal to A transpose. Both are same only here. So A transpose will be 1, 5, 3, 2. Right. So what I am going to do is, first I am going to generate the symmetric matrix by adding these two. So by adding these two, what I will get? 2, 8, 8, 4. Okay, this will be definitely a symmetric matrix by our property. Then I am going to subtract it to get my skew symmetry. If I subtract, what I will get? 0, minus 2, minus 2, 0. Okay. So here it will be plus 2. So these two matrix, we say it as, this is symmetry matrix and this is skew symmetry matrix, right? Okay. Now what I am going to do, I am going to apply in this equation. That is 1 by 2 of 2, 8, 8, 4 plus 1 by 2 of 0, minus 2, 2, 0 will be, how it is going to be? So 1, 4, 4, 2 plus 0, minus 1, 1, 0, right? If I add these two matrix, what I will get? 1, 3, 5, 2. See what I have taken initially, that came, that is which is equal to A. So that what they say is, if I am taking any matrix and if I am taking a symmetric and skew symmetric, dividing it by both by 2 and adding, then this is the expression of sum of symmetric and skew symmetric. We can express any matrix, as the sum of symmetric and skew symmetric. So this is very important, that is express the matrix as the sum of symmetric and skew symmetric. So I want to take it as A. So what will be my A transpose? That is 3, 1, 5, minus 1, right? Now I can able to add these two. A plus A transpose is going to be, so what is the formula, you remember? So A is equal to 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose, right? So A plus A transpose is going to be, so what I'm 6, 6, 6, 0. So this is A plus A transpose. And what is my A minus A transpose is going to be? A minus A transpose is going to be 0, 4, minus 4, 0. Now this is A minus A transpose. So I know that I am going to substitute here. So 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose is going to be equal to 1 by 2 6, 6, 6, 0 plus 1 by 2 0, 4, minus 4, 0, which is going to be 3, 3, 3, 0 plus 0, 2, minus 2, 0. Okay, so we can stop here because they asked to express the matrix in sum of symmetric and skew symmetric. So this is from this where we can stop. But if I continue this, what I will get? I will get the same answer of A, 3, 5. So next important operations of matrix is elementary operation. What we mean by elementary operation is, if whatever operation we did with two matrices. Now we are going to do an operation within a matrix. If I have a matrix, within that matrix itself we will do a operation. There are 6 important operations in the matrix, that is elementary operations. What are they is, first interchange of any two rows or column. That is, if I am having 1, 2, 3, 4, 5, 6, 7, 8, 9, I can interchange any two rows or two columns in a matrix. That is known as first elementary operation. That is, I can write like this. That is, I am interchanging my first row and second row. That is 4, 5, 6, 1, 2, 3, 7, 8, 9. So this is interchanging of rows. The same way I can even interchange the column. I am interchanging the first column and last column, I will so if I do this, I want to write like, now I interchanged R1 interchanged with R2, right? My R1 R2 is exchanged, so I will write this like this. Similarly, if I am going to interchange the columns now, so I will write C1 is interchanged with C3, so 3 will come here and first column will go there. So this is the first important elementary operation that you need to know. Okay, the second important operation is multiplication of elements of any row or column. If I am having a matrix, like example for like this 1 2 3 4 5 6 7 8 9. Now suddenly I want to multiply a number, a single number, to any one of row or column of the matrix, then I can represent like this. If I am going to multiply the second row, so second row will be multiplied by 3 or 2, that is second row will be 1 second multiplied by 3 like scalar multiplication, but only second row will get affected, that is A is equal to 1 2 3 12 15 18 7 8 9. So this is how this operation also can be done for column, so I can write like this also. So I can write C1 is equal to 2 in 1 by 2 into C1, we can write that. So even we can multiply a fraction number to show that I am doing this. So what I will do, 1 by 2 1 by 4 by 2 7 by 2, so I multiplied 1 by 2 to the first column and remaining elements will be as it is, no change in that elements. So this is second operation, that is multiplication of rows of any row or column. Okay, and the third important operation of a matrix is addition of elements of any rows or column, the corresponding element of any row or column multiplied by any non-zero number. That is, if I am having a number like this, matrix like this, and I am trying to convert my R1 equal to R1 plus 2R2. What it means is, I am going to multiply a R2 by 2, then I am going to add to R1. So what will be my answer? So R1 will be changed 1 plus 8. Why? Because 8, since it is 4 here, 4 2s are 8, so I am going to, it is going to be 9 at last. So here 10 it's going to be, so here 2, so it is going to be 12. Similarly here 6 2s are 12, 12 plus 3 is going to be 15. Then any other things will not change, it will come as it is, since we wrote a operation, elementary operation only to change R1. R1 is this, so only R1 will be changing. This is known as elementary operation of matrix. I wrote 6 operation, but I teach only 3, right? Because why it is 6 is 3 for rows and 3 for columns. I can interchange 2 rows or I can interchange 2 columns. So this made 2 operations, that is, so similarly for all 3, so it became 6. Next is invertible of matrix. So what is invertible is, if I am having a matrix A and if I am having a matrix B, if I multiply these two matrices, then I will get the identity matrix. Then this matrix is known as invertible. That is, if I am having a matrix A, now 1 2 3 and 1 3 are the one matrix, and 2 minus 3 minus 1 2 are the another matrix. If I multiply these two number, I got the matrix which is identity matrix. So I will say this as an invertible matrix. That is, here AB will be equal to BA. Okay, if I do the same thing, that is if I did AB, so you know generally that the matrix multiplication is not commutative, right? But in this form we will get commutative. That is, if my A and B is multiplying and getting the identity matrix as a resultant, then if I multiply my B and A, then also I will get the matrix identity as my resultants. So this is called invertible of matrix. Okay, so there is another thing also. If I am having a matrix A and I am getting multiplying with one another matrix, I am getting identity as an element resultant, then this matrix is known as A inverse. Okay, that is, if I want to get an identity element, I want to multiply it to a inverse, right? If I am having a and if I am multiplying with A inverse only, then I will get identity element. So here A inverse, this part is going to be B. So I am getting identity as an resultant. Okay. So another important property of not property is operation of matrix is determinant of matrix. We even have a new unit called determinant in your 12th. But how to find a determinant? Here it is a single operation. How to find the determinant is, if I am having a 2 cross 2 matrix, first you want to note that determinant of the matrix can be found only for a square matrix. Now this is a square matrix, right? For this only I can able to find the determinant. So you know what is square matrix? Square matrix means the number of rows and number of columns should be equal, like this, right? Then only I can able to find that determinant. If I am having like this is 2 cross 2 matrix. I will take like this. If I multiply these two number and multiply these two number and subtract, what is the answer is known as determinant. That is 1 into 5 minus 2 into 6. So what will be 5 minus 12, which is going to be minus 7. So this is the determinant of this matrix. So how to find the determinants of 2 cross 2 I taught you. How to find the determinants of 3 cross 3 that we are going to see. So before going to that, now minor. What is minor of your matrix? If I am having a matrix, let it be 2 by 2 matrix. Minor of 3 is 6, minor of 4 is 5, minor of 5 is 4 and minor of 6 is 3. So you find that, guys, that is if I am having a matrix, that opposite elements is said to be minor. This is minor of the 1, this is the minor of this one, this is minor of 6 and this is the minor of 7. So this is how the minor element is found in 2 by 2 matrix. If I want to find a minor of 3 by 3 matrix, if I want to find the minor of 3 by 3, this is 3 by 3 matrix, right? What I am going to do, if I want to find the minor of this element, see, minor of an element, minor, all the element has each one minor. Okay, so 9 element is there, so we will have 9 different minors. Okay, so if I take this element, if I want to find the minor of this element, first what I will do, I will eliminate the row and column where it is. I will eliminate the row and column where it is. Now I will find a 2 by 2 matrix. For 2 by 2 matrix, we need to know how to find the minor, right? So similarly, if I want to take for A22, what I will do is, I will clear this and say, so what I will do is, for A22, it is in the second row and second column, so I will have other 4 elements, right? So whatever, if I eliminate a, whatever related me for A33, what I will do, if I want to do for A33, I will eliminate the third row and third column and I will have 4 elements. So these 4 elements will be there. Using these 4 elements, we know how to find the minor of 2 cross 2 matrix, we can find the minor. So this is how we want to find the minor for 3 cross 3 matrix. Okay, anyway, I will teach you one new sum using numbers, then it will be more clear. We can take this as a matrix, 3 by 3 matrix. Now I want to find the minor of all the elements. What I will do, so minor of 1, that is first element here, or I can even take it as A11. What I will do, I will leave first row and first column. What is remaining then? 4, 5, 6, 7. I know to find out to find the minor of this 2 cross 2 by 2 matrix, that is this is equal to 28 minus 30, it is going to be minus 2. Similarly, minor of A12. So I will leave the second column and first row. What is the remaining? 1, 5, 7, 7. It is going to be 7 minus 35. It is going to be minus 28. So this is known as minor of the matrix. This is, like this we can find even for A33. For all the elements we can find the minor. A33 I will leave the third row and third column. What will be my remaining? 1, 2 and 1, 4, which is going to be 4 minus 2, which is going to be 2. Okay, so this is how I want to find the minor. Okay, so another important operations. Okay, so that what same thing was explained in the numbers. Okay, next what we are going to do is, how to find the cofactor. See guys, we started with transpose, how to find the transpose. Then we came for elementary operations, and there are 6 elementary operations, 3 depends on row and 3 depends on column. And next we came to how to find the minor, how to find the determinant of 2 by 2 matrix. Still I not taught how to teach the 3 by 3 matrix determinant, that I will teach after this thing. And we find how to find the minor of 2 by 2, and we came to how to find the minor of 3 by 3 matrix. Now we came to cofactor. So how to find a cofactor is, if I am having this is the formula, no need to mug up this and all, I will say easily. What we have to do is, if I am having a matrix, for example, let me take like this. Okay, we know what is the position of this element, right? A11, A12, A21, A22. So in this we will say ij, right? So this is I is number of rows and j is number of column. If my I plus j is odd, then I will use negative. Then I will use negative of minor. Negative of minor. If my I plus j is even, then I will use as it is what minor, I am use the minor itself. That is, what will be the minor of A11 here? 1. I am writing only minor now. Minor. So similarly, minor of A12 will be 3. Minor of A21 will be 2. Minor of A22 will be 1. Okay, this is minor. To find a cofactor, I will write cofactor of A11. So I have 1 plus 1, right? I is 1 and j is 1. So 1 plus 1 is 2. 2 is even. So I will write my minor as it is. Similarly, here A12, 1 plus 2 is 3. 3 is odd. So I will use negation of my minor, that is minus 3. You understand, people? So what I am going, once again I will proceed this sum, you will understand now. A21, if I add this 2 plus 1, what I am getting? 3. If I get 3, 3 is odd or even? It is even. Odd, sorry. If it is odd, so I will use negative of this number, that is minus 2. So cofactor of A22 will be 1, because 2 plus 2 is 4, which is even. So now I will write like this: 1 minus 3 minus 2 1. This is known as cofactor. Cofactor of A, generally AC. Okay, so this is how we want to find the cofactor matrix of a 2 by 2 matrix. Okay, what happens if it is 3 cross 3? Nothing, same thing. We know how to find the minor of 3 by 3 matrix, right? We know how to find. So what I will do, I will find the minor first. I will find the minor of all the elements from A11 to A33. I will find all the elements, that all 9 elements I will have. Then I will check 1 plus 1 odd or even. This I plus j I will check. Accordingly I will put plus or minus. So this is known as cofactor of a matrix. Okay, now this is the time to study determinant of 3 cross 3 matrix. Why I left this is, now you will understand, because for finding a cofactor, determinant of a 3 by 3 matrix, we may need for minor and cofactor to be in account. So that's why. So now what I will do, let it make it clear, 3. So what I am going to do, first step for 3 by 3 matrix determinant. So determinant will be expressed as 2 lines, and between I want to find the determinant now. First step what he has to do is plus minus plus. I want to put this number here. So what I will do, then I will find the minor of 1. How I will find the minor of 1? And like this, right? I will leave the row and column where the 1 is. So what is the remaining? 7, 2, 3, 1, and multiply that number. Similarly, here I have minus, So I will put minus 3. I will leave this row and this column. What remaining I will have? 4, 2, 1, 1. That is, I left this one and this one. So similarly, I am going to make, next is plus 1, right? So I want to put plus minus plus first, then I want to continue like this. So what I will do now, I will leave these two, that is this row and this column. What I will have remaining is 4, 7, 1, 3. So now if I find the determinant of this, 7 minus 6 minus 3 into 4 minus 2. So these are minors. So minus what I will do, I am doing the same thing. Plus 1, 12 minus 7. So 1 into 1 minus 3 into 2 plus 1 into 5. So 1 minus 6 plus 5, which is going to be 0. Okay, this is how you want to find the determinant of 3 by 3 matrix. Okay, so cofactor, everything now you know how to find. Next is adjoint of your matrix. How to find the adjoint of matrix? So adjoint is nothing but taking a transpose of cofactor matrix. Taking the transpose of cofactor matrix. If I am having a matrix, you know how to find cofactor matrix, right? I am having a matrix this. So first I will find the minor. So now you know what is the importance of minor. Minor is the basic operation for all the things, for finding cofactor, adjoint, determinant, everything. So minor of 1 will be 4 here, minor of 2 will be 3 minus here 3, and minor of 3 will be 2, and minor of 4 will be 1. So what will be the cofactor? What will be the cofactor then? AC of 1 will be equal to 4. 2 will be minus 3. Why I am putting here? Because it is A12, A21. These both are odd. So I am changing the sign of that number. So what cofactor I will get is 4 minus 3 minus 2, 1. Now I am taking transpose of this matrix. If I take the transpose of this matrix, then I will get like this, right? This is known as adjoint of your matrix. This is known as adjoint of the matrix.